In our extra lesson, we talked about congruency. Okay, and we said that congruent shapes specifically, have exactly the same shape and size, and that they are terrible twins. Okay, the symbol for congruent is like an equal to sign, but with an extra line. And in congruent triangles specifically, each side has a partner in the other triangle that is equal to it, and a side that is equal to it, and another one that is equal to it. And then each angle has a partner, and each angle has a partner, and each angle has a partner. And if they don't have partners, or if they're not in the correct order, then they're not congruent. Okay. We mentioned that the order in which the names of the triangles are written is important. So for example, if it's triangle ABC congruent to triangle DEF, then angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. And that AB, side AB, is equal to side DE. That side BC is equal to side EF, and side AC is equal to side DF. Okay. We mentioned that we don't need to prove all of these conditions to prove that a triangle is congruent to another one. Okay, there are 4 cases, and each case has 3 conditions that need to be met. So the 4 cases are side, 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 where if you can prove that one side has a partner, another side has a partner, and the third side has a partner, then the triangles will be congruent, and from that you can then say, but then the angles will have partners as well. By the way, we call these partners corresponding sides and corresponding angles. I refer to them alternately so that you can remember it easily. Okay, so the second case is side angle angle or side angle angle. It doesn't matter whether you write it like this or like this. This isn't an L, it's the symbol for angle. Okay, so where you have 2 angles that have partners and 1 side that has a partner, and it doesn't matter which side or which angles, as long as it's 2 angles and a side. When you have those 3 conditions, then you can say the triangles are congruent, and then you can assume that the other angle, and this is just popping up, that the other angle and the other side are equal. Okay. Then the third case is side angle side. Now this one is very important because this angle must be in between 2 sides. Okay, so it's 2 sides and then the included angle. So you'll see I made a Pac-Man little here because that's the top of the mouth, the bottom of the mouth, and if the angle is not inside the mouth, then it's not side angle side. Okay, if you have side angle side, then the angles are the triangles are congruent and all the other conditions are met. And similarly, right angle hypotenuse side is a special one. It can only be used in a right angle triangle. Any of these can also be used in right angle triangles, but this one is only for right angle triangles. So this is right angle, hypotenuse, and side. So if you have 2 right angles, so a partner and the hypotenuses, and then another side that have partners, then the triangles are congruent and everything else will be met. Okay, we did this example, and then we got to proving triangles are congruent. Okay, So we said that you need to prove one of the cases, and then you can say that the triangles are congruent. So we did this example, we did this example. They are in the previous video. And we did this example, also in the previous video. All right. And then let's get to the new work. Okay. So this example says, consider the triangle ABD, ABD, and triangle CBD, CBD. Okay, prove that triangle ABD is congruent to triangle CBD in two different ways. All right, now this can be quite difficult to do if you're unsure how to start. Okay, so I'm going to redraw these triangles just roughly for myself. This is not for anyone else but me. Okay, and then I say, okay, so what do I have? I know that this angle is 90 degrees, so that angle is 90 degrees. Angles on a straight line means that is also 90 degrees, so we have a 90-degree angle in both triangles. Okay, then we have the hypotenuse in each triangle. We know that this side is equal to that side, that is given. Okay, and then we have one more thing that's a little bit more difficult to spot, that BD is equal to BD. That side is equal to that side because it's a common side. They share it. Okay. So if you write this down, let me just see if I can extend this a little bit. There we go. Okay. So we want to say, we know that angle B1 is equal to angle B2, both are 90 degrees. We said that first because they are angles on a straight line. And one was given as 90 degrees. Then we said that side AD is equal to side CD. That was given. And those are the hypotenuses. So we have right angle, hypotenuse, and then we said that BD is equal to BD because this is BD there and this is BD there. It is a common side. So now we have our three conditions: right angle, hypotenuse, side. Therefore, triangle ABD is congruent to triangle CBD. And our reason is right angle, hypotenuse, side. That was quite easy, actually. Okay. Then there's another way that we can do this. Okay. So let's look at the big triangle. The big triangle looks like this. Okay. You know that that is equal to that. Okay. That means that this angle is equal to that angle, right? Because angles opposite equal sides are equal. So that angle is equal to that angle. That means that this angle is equal to that angle. Okay. So now in the two triangles, and I'm just redrawing them so I can indicate to you what I'm using for this one. We have right angle, side, side, and another angle. So this is side angle, angle. Okay, so how am I going to write that? Well, we said that angle B1 is equal to angle B2, angle B1 equal to angle B2, because they're both 90 degrees, they're angles on a straight line. Okay, then we said angle A is equal to angle C, angle A is equal to angle C because they're angles opposite equal sides. And then we said side AD is equal to side CD. Side AD is equal to side CD. That was given. Now we have an angle and a side. So we have side angle, angle. I'm just going to write it down here. Triangle ABD is congruent to triangle CBD because of side angle. And that's two ways. All right. Then the second question here asks, prove that BD bisects angle D. Okay, sorry about that. Let's just do that again. Okay. So it says prove that BD bisects D. Okay, BD over here, and we want to prove that it bisects angle D. In other words, that angle is equal to that angle. Okay, so we want to prove, and you don't need to write this down, this is just for you for later. We want to prove that angle D1 is equal to angle D2. Well, because we have that triangle ABD is congruent to triangle CBD, you know that angle D is equal to angle D. Okay, so we can actually say that angle D is equal to angle D because the triangles are congruent. Okay, therefore, we can say triangle ABD congruent to triangle CBD. That's proven. And we can say D1 is equal to D2 because corresponding angles in congruent triangles are equal. Okay, you can also just say this as your reason. Okay, you can practice this in exercise 4 on page 159 and 160, but you can also practice it on your worksheet that you were handed in class.